Here is my next video on the nodal analysis. So here the question is, he's asking us to find Ix by using nodal analysis. Okay, so whenever it comes to the nodal analysis, we always use Kirchhoff's current law. So we always use KCL. Okay, that needs to come into your mind. Step 1, always find all the nodes and label the node voltage as V1, V2, V3 or VA, VB, VC. So here is one node V1, here is another node V2, V3. Okay, do we need to label this as another node? You can label it, but it's not going to make any difference, or it's no use. I will talk about it V4, but I'm going to label it for time being. And the bottom one as V reference. I'm going to label that as 0. Bottom is reference node 0. So that's our step 1. Step 2, see if there is a voltage source between V reference and any other unknown node voltage, because we know reference node voltage as 0. We know only that voltage, but we don't know V1, V2, V3, V4. So check if you have any voltage source between any one of these 4 here. So I don't have any voltage source here. 3 ampere is a current source, 7 ampere is also current source. So we can skip step 2. Okay, step 2 is check if you have any voltage source between V reference and any unknown. If you have that voltage, then unknown node voltage equal to same as the source voltage. So here I don't have that. If you do not understand clearly, see my first video. So it is the first example in the first video. Here I have V1 unknown and V reference is 0. So V1 minus V reference must be equal to 20. V1 minus V reference equal to 20. I have V reference equal to 0, so I can take V1 equal to 20 volts. Okay, so if you have voltage source, you can find the voltage at that node by using this. But in this example, we don't have any voltage source, so we can skip step 2. Now at each node, apply KCL. So at V1, apply KCL. Okay, so if I apply KCL, V1 minus, so assume every current is going away. So I'm going to choose I1, I2 and I3. Okay, I1 plus I2 plus I3 equal to 0. I1 is nothing but V1 minus V2 over 1. I2 is nothing but 3. My I2 direction and 3 ampere, both of them in the same direction, so I2 is nothing but 3 ampere. Okay, so I2 is nothing but 3 ampere plus I3 is nothing but V1 minus V3 over 2 equal to 0. So to eliminate the denominator, I'm going to multiply this with 2. So 2V1 minus 2V2 plus 6 plus V1 minus V3 equal to 0. I have 3V1 minus 2V2 minus V3 equal to minus 6. This is my first equation. Okay, now second equation, at V2 apply KCL. At V2 apply KCL. Okay, so here I'm going to label different IA, IB, IC. So IA plus IB plus IC equal to 0. What is IA? I told you why I'm choosing every current is going out, because every equation, so when you're writing equation at V1, it is always V1 minus something. When you're writing equation at V2, it's going to be V2 minus something. So IA is nothing but V2 minus V1. So V2 minus V1 over 1 plus IB is nothing but V2 minus V reference, which is 0 over 3, plus IC is nothing but V2 minus V3 over 4 equal to 0. Okay, here this voltage and this voltage is same, V reference, because I told you since there is no element, this node and this node, both of them are same. Okay, another way of choosing this is basically you can connect everything right there. Okay, so all 4 nodes are connected at this reference node. Okay, so that's the reason with voltage at this point, voltage at this point, voltage at this point, everything is 0. Now simplify this. So to simplify it, I'm going to multiply with 12. 12 is the common factor for 3 and 4. So I end up with minus 12v1 plus 19v2 minus 3v3 equal to 0. This is my second equation. Now third equation, at v3 apply KCL. Okay, at v3 apply KCL. My C look like L, so don't get confused. So here, how many branches are there? There are 4 branches at v3. So I'm going to take each branch as, let me use different color. I'm going to use blue. So here is every current. I'm going to choose up to as I1, I2, I3 and I4. All 4 currents are. So I1 plus I2 plus I3 plus I4 equal to 0. Now to write I1, okay, I1 here I can write this as I1 equal to V3 minus V4 equal to 6. I can do that. That will increase my number of equations. Okay, instead of that, can I write, since this I1 is not splitting anywhere, right? So the current passing through this is also I1. Can I take directly I1 equal to 7 ampere? Okay, I can choose I1 equal to 7 ampere instead of doing this. This equation is also right. I'm not saying that's wrong, but that will increase your calculations. Okay, so to minimize the calculations, I'm taking I1 equal to 7 amperes directly. That makes my, instead of having 4 equations, I will end up having only 3 equations, 3 unknowns. So I'm going to choose I1 equal to 7 ampere. So everything else is same. So here I1 equal to 7 ampere plus I2 is the current. That's I1 current going here. I think I chose this as I2 equal to V3 minus V2 over 4, V3 minus V2 over 4 plus. So here I2 equal to V3 minus V2. So here is my V3 minus V2 over 4 equal to I2, and I3 equal to V3 minus 0 over 5 equal to I3, and I4 is nothing but V3 minus V1 divided by 2 will give you I4. Okay, so I end up writing the equation 7 plus V3 minus V2 over 4, V3 minus 0 over 5, V3 minus V1 equal to V3 minus V1 over 2 equal to 0. This is our third equation. Let me simplify this offline. So to simplify it, I'm multiplying with this equation with 20. So I end up with minus 10V1 minus 5V2 plus 19V3 equal to minus 140. That's third equation. So we have 3 unknowns, 3 equations. So I'm going to write it down. So these are the 3 equations, 3 unknowns. You can plug in these 3 equations in your calculator and find V1, V2, V3, or there is a substitution method. Here in this example problem, I'm going to solve it by using substitution method. So here what I'm going to do, to eliminate V1, I'm going to solve these 2 equations. First, let me multiply this with 4. Okay, so if I multiply this with 4, 12V1 minus 8V2 minus 4V3 equal to minus 24. Minus 12V1 plus 19V2 minus 3V3 equal to 0. So here I'm adding these 2 equations. So I end up with 11V2 minus 7V1 V3 equal to minus 24. Let me label this equation as 4. Okay, now I'm going to solve equation 2 and equation 3. What I'm going to do, I'm going to multiply with the coefficients. So here minus 10v1 minus 5v2 plus 19v3 equal to negative 140. I'm going to multiply this with 12, negative 12v1 plus 19v2 minus 3v3 equal to 0. I'm going to multiply this with 10. So when I multiply these two, what I'm going to do, I'm going to subtract these two. So this minus become plus, minus, plus. Okay, so these two get cancelled out here. Minus 190 minus 60, which is minus 190 minus 60, minus 250 v2 plus 258 v3 equal to negative 1680. I'm going to label this as equation 5. Now equation 4 and 5. So equation 4, I have 11 v2 minus 7 v3 equal to minus 24. I'm going to minus 24. So let me simplify these two equations. So I'm simplifying equation 5 and 4, multiplying equation 5 with the coefficient of v2 in equation 4, and same thing, equation 4 is multiplied by coefficient of v2 in equation 5 to eliminate v2. So I end up with v3 equal to minus 22.5 in the calculations. Once I have v3, substitute v3 in equation, this is equation 4, you can substitute in equation 4. So 11 v2 minus 7 times v3, which is minus 22.5 equal to minus 24. So if I substitute v3 value in equation 4, I end up with v2 equal to minus 16.5. Now substitute v2 and v3 value in equation 1, 2, 3, any one of those two. You can find v1 value. But what is our final goal? Here he's asking for ix. To find ix, all I need v2. So ix equal to, in the given equation, ix equal to v2 over 3. v2 is minus 16.5 over 3. That value is minus 5.5 amperes. Okay, so ix is flowing in the opposite direction. That's, you can clearly see from the given circuit, because the currents are going down, right? So these currents are going down. How come I'm choosing this as a reference node? It doesn't make any difference, as I mentioned. Maybe in reality this might not be the reference node, this might be the reference node, or any other node might be the reference node. We don't need to worry. All our goal is finding ix. So I found ix equal to minus 5.5 ampere. That indicates that the real current is going up. Positive 5.5 amperes is going up towards v2. Thank you. I'll stop this video here. Thank you. I'll solve more examples in the next videos.